Today we're going to be doing the Unit 8 review. So we're going to be talking about stuff with radicals and simplifying radicals. So let's go ahead and let's take a look at number 1. So remember to break down these radicals, what you need to do is split it into pairs. So for example, this splits down to 25 and 2, and 25 splits down to 5 and 5. So underneath the radical you have 2 times 5 times 5. And then you can take out a pair of 5s. So if you have a pair, you can come out of the radical, and you're going to come out as 1. So that's just 5. And left underneath the radical is 2. So we have 5 square root of 2 for number 1. Taking a look at 75, we have 25 and 3. And 25, I could split down to 5 and 5. So then I'm going to go ahead and write this under the radical. So I have 3 times 5 times 5, and then I have 2 x's. So I draw out 2 x's, and I have 3 y's. So I'm going to write out 3 y's. Now I'm going to take out as many pairs as I can. So I can take out a 5, an x, and a y. And then left underneath the radical is 3y. So this right here is your final answer for number 2. Now taking a look at number 3, we're taking 12 and bringing it down. So that's 4 and 3. And 4 you can split down to 2 and 2. So I can take out a pair of 2's. Now when I take out that pair of 2's, I need to make sure I multiply it by the number that's originally on the outside. So 5 times 2 is 10. And then left under the square root is 3. So that's your final answer for number 3. Now let's take a look at number 4. So remember that to add and subtract radicals, you need to have the same number underneath the radical. So we can add those two terms together because they both have square root of x. So 5 square root of x minus 3 square root of x is 2 square root of x. And then we're going to leave the square root of 2 by itself. These two cannot be added because they have different radicals. So that right there is your final answer for number 4. Now let's take a look at number 5. We're going to take 27 and split it down to 9 and 3, and then 3 and 3. So I have 4 square root of 3 on the first one. Then from 27, I can take out a pair of 3's. So I'm taking out a pair of 3's, and then left underneath the radical is 3. So now what I have is 4 square root of 3 minus 3 square root of 3. Well, I can actually add those out, and I get 1 square root of 3. So that's your final answer for number 5. So let's take a look at number 6. We need to multiply outside to outside. So we're going to multiply 2, and then when there's no number, there's basically a 1 out front. So we're going to multiply outside. So 2 times 1 times 4. And that's going to give us 8. Then we're going to multiply underneath the radical, which is 3 times 2 times 3. And that's going to give us 18. Now we're not done. Whenever you get to the end of any radical, you need to make sure you simplify. So 18 we can break down to 9 and 2. And then 9 we can break down to 3 and 3. So here I could take out a pair of 3's, and I'm going to multiply that by the 8. So 8 times 3 is going to give me 24. Left without a pair is this 2. So then left underneath the radical is 2. So I have 24 square root of 2 for number 6. Taking a look at number 7, we need to multiply this out using the box method. So I have 3 square root of 5 and 3 minus square root of 5. So then to multiply into the box, 3 times 3 is 9. 3 square root times square root of 5 is 3 square root of 5. Negative square root of 5 times 3 is negative 3 square root of 5. And negative square root of 5 times negative square root of 5 is negative 5. Okay? Let's do it this way, is negative square root of 25. We'll deal with that in a second. So then I have 9, 3 square root of 3 and negative 3 square root of 3 are going to cancel out. Then I have minus the square root of 25. Well, 25 I can split down into 5 and 5. And since everything ended up in a pair, that means it is a perfect square. So I can take 9 minus 5, and that's going to give me 4. So my final answer for number 7 is 4. Let's take a look at number 8. So we have square root of 1 divided by square root of 3. So what I did was I split it up. We're going to be doing some rationalizing of the denominator here. So I split that up into 2 separate radicals. Well, 1 and 3 cannot be simplified. Remember that we don't want a square root on the bottom. So we're going to multiply by the square root of 3 over the square root of 3. So now I'm going to multiply across the top. 1 times 3 is 3. And square root of 3 times square root of 3 is just 3. Whenever you multiply the same radical times itself, it's just the number that was underneath the radical. So this is your final answer for number 8. Now let's take a look at number 9. We're going to do square root of 3, and then I'm going to split it up to be square root of 8x to the third. Now before I go any further, I actually want to break down 8x to the third and simplify that radical. So for 8, I can split that into 4 and 2. and then 2 and 2, so I can take out a pair of 2's. And x to the third is the same as having 3 x's, so I can also take out a pair of x's. So then I get square root of 3 divided by, on the outside I can take out 2 and x, and then left without a partner on the bottom is square root of 2x. So that needs to stay underneath the radical. So now what I need to do in order to get rid of that radical on the bottom is I actually have to multiply by just the radical that's on the bottom. So notice that I'm just multiplying by square root of 2x over square root of 2x. So now I'm going to multiply underneath the radical. So 3 times 2x is 6x, and that's going to be underneath the radical. And then I have 2x. Square root of 2x times square root of 2x is just going to give me 2x. So then I have the square root of 6x, and now I can multiply the bottom. 2 times 2 is 4. X times x is x squared. So that's your final answer for number 9. Now let's take a look at number 10, so solving radical equations. So the first thing I want to do is get that radical by itself. So I need to add 7 to both sides. So I get the square root of x is equal to 7. Now remember, when the radical is completely isolated, it does need to be set equal to a positive number. So what I'm going to do now is square both sides because that radical is now isolated. So when I square the square root of x, I'm just left with x, and 7 squared is 49. So that right there is your final answer for number 10. Taking a look at number 11, first thing I want to do is get the radical by itself. So I'm going to go ahead and subtract 9 from both sides. So then I get the square root of 2x minus 3 is equal to 5 minus 4. Or minus 9, which is negative 4. So since this is set equal to a negative number, that means that there is no solution. Okay, so let's take a look at number 12. So for number 12, the radical is isolated, so we're going to have to go ahead and square both sides. So then I get the square root of 4x minus 3 is equal to x squared. Oops, and I don't need the radical anymore because I squared both sides. So what I have here is a quadratic, so I need to actually subtract 4x plus 3 to both sides. So I get x squared minus 4x plus 3 is equal to 0. So in order to solve this, I have to actually solve using the x. So I'm multiplying to 3, adding to negative 4. That's going to be negative 3 and negative 1. So x minus 3 times x minus 1 is equal to 0. So I'm going to set each of those equal to 0. So I get that x is 3 and I get that x is 1. Now before I'm done, I need to test those out. So I need to plug them back into the original problem. So plugging in 3, I get 4 times 3 minus 3, substituting each of those x's out and putting in a 3 instead. 4 times 3 is 12, minus 3 is 9. So I get the square root of 9 is equal to 3, and then I get that 3 is equal to 3. So 3 works out. 3 is a solution. Now I need to check 1. So 4 times 1 minus 3 is equal to 1. So then what we need to do, look at all those emails I got. I'm a popular lady. So then 4 times 1 is 4, minus 3 is 1. So I get the square root of 1 is equal to 1. So then I get that 1 is equal to 1. So x is equal to 1 is also a solution. So let's take a look at the Pythagorean theorem. The Pythagorean theorem is simply a squared plus b squared is equal to c squared. And now Pythagorean triple are 3 numbers that make a right triangle. Okay, so the Pythagorean triple are 3 numbers that make a right triangle. Okay, so let's go ahead and let's take a look at applying these two properties. So for number 13, we know b and we know c. So what we don't know is a. So a squared plus 11 squared is equal to 21 squared. So when I get a squared plus 121 is equal to 441. Subtract 121 from both sides, and then we get a squared is equal to 321. So then we're going to take the square root of both sides, and then we have a is equal to the square root of 320. So now we need to break this down, okay? I don't want decimals, I want a nice simplified radical. So 320 can be broken down to 32 and 10. 10 can be broken down to 5 and 2. Well, 32 can be broken down to 16 and 2, and 16 can be broken down to 4 and 4. Since I already have a pairs of 4 there, I don't need to go down and breaking each down to 2 and 2 because I already have a pair. And then I have 2 and 2 here. So I could take out a pair of 4s, I could take out a pair of 2s, and then left underneath the radical is 5. 4 times 2 is 8, and then it's square root of 5. So that's your final answer for 13. Now, if you were to get a problem and they're asking you to find a Pythagorean triple, like on number 14, we want to see if it's a Pythagorean triple. So what we need to do is see if the two smaller sides squared are equal to the larger side squared. So 10 squared is 100, 24 squared is 576, 26 squared is 676. So 100 plus 576 is 676. Is 676 equal to 676? Yes, so these do make up the sides of a right triangle, and that's how you use that Pythagorean triple idea. Next is the distance formula. So the distance formula goes like this. So we have x2 minus x1 squared plus y2 minus y1 and then squared. Now these are taken from points x1, y1 and x2, y2. So it doesn't really matter which one's x1, y1, which one's x2, y2, as long as your x1 is with your y1 and your x2 is with your y2. So let's go ahead and let's calculate out the distance formula. So I like to label my points, x1, y1, x2, y2, just to make sure I stay consistent. So then I'm going to do y2 minus y1. Now remember, when you subtract a negative, it becomes plus a positive. And then x2 minus x1. Oops, I flipped them around, but it still works. You can do y2 minus y1 or x2 minus x1 first. That's my fault. So 7 plus 1 is 8, and then 11 minus 5 is 6. So 8 squared is 64, 6 squared is 36, so then I end up getting the square root of 100. Well, I happen to know my square roots, and I know that the square root of 100 is 10. Now let's take a look lastly at number 16, x1, y1, x2, y2. In case you guys are wondering, I now have 7 unread emails. I'm sorry that keeps popping up. So I'm going to do x2 minus x1 squared plus y2 minus y1. Remember, when you subtract a negative, it becomes plus a positive. Now, here's the deal. Here, when you subtract negative 2 minus 4, it's going to become more negative, and then you're going to square it. Negative 5 plus 1 is negative 4, and then you're going to square it. Now, I want you to be very careful about how you use parentheses. Remember that when you square a negative number, it becomes positive. I guarantee you one of the options for your multiple choice on the final is if you made the mistake and said that a negative number squared was negative. So please be wary of that. So then you have 36 plus 16, and then we have the square root of 52. So now I need to break that down into pairs. So I can divide 52 by 4, and I get 4 and 13, and then I get 2 and 2. So I have a pair of 2's that I can pull out, and left underneath the radical is 13. So 2 square root of 13 is my final answer. So that concludes your note video for your Unit 8 review, and again, there is no Schoology quiz.